Okay, now what I'm going to do here, because this overlap thing is so important and obviously not used generally. Most programs don't use it. I never used it until today. And I guess part of the reason that I never used it was that I didn't realize the importance of it. I mean, I thought that it might be something that would be important, with a great big program, or some flight simulator or something like that. Not a little editor thing that tries to open a file. But it turns out that it's important. It's that important, and the fact that nobody uses it, it just comes from experience. I know that quite often my system gets into a state where it's hung. I mean, it's not responding. It's not responsive, and I blame the operating system. Well, the operating system might be partly to blame in that, it could sort of, behind the scenes, disallow the kinds of operations that would cause the system to, become in a deadlocked state. And the runtime library too is partly to blame. I never thought for a minute that fread took those arguments seriously. Fread. I was just looking it up. This is not what this was printf before, but these are the arguments to fread. Right? It has the buffer, size, and count. Right? Size is generally like and then the size. This is supposed to be like elements might be something in a database, like a struct or something. So you might say size of my record or something, and then the number of records you want to read, 10, right? And then a pointer to a file, and it returns a size t, size type, records, right? It doesn't return the number of bytes read, it returns the number of elements read. And that can be useful if you're reading strings where the size of one element is a wide car, right? Now, if it's the entire file you want to read, right? There's two ways you could write it down. You could write it down this way. You've worked out the size of a file. I got the D word. One. Right? I would like to read one unit of size file. So you could say file is read. And you should assert that that's equal to 1. Right? I don't know if that function's available. That's what I've got here. But you know what I'm saying. I hope you know what I'm saying. The thing that I wouldn't never have dreamt might have mattered is if you reverse these, right? This says to read this many objects of this type. So that would involve this many read operations. In theory, I don't believe it does. I think it reads, it can only read, I know it can only read a minimum. There's a minimum amount it can read. Watch, let's suppose I open a file. Yeah, no, I think these things are on Windows.h or something. Standard IO. Error type error equals, I got T card there, address of the pointer, and a contact of, I'm using T cards. So I don't want to take that huge file. I'll take the second next bad file, raw file. Right. File name and mode binary. Error return what? Right? Now, if I wanted to, I could compute the file size. There are several ways to go about it, but I'll just use the easiest possible way. Long and equals 0 for now. Seek pf. Now to get to the end, you specify an offset of 0, and the origin there are special defines for this. I think it's seek end, like that. Yeah. So that means that the current read position is at the end. So now I can say, and define this here. Alright, tell me where you are. And since I'm at the end, L pause end here, assuming it's a positive value, is the size of the file. So if now I don't think this thing can return, and maybe no returns long. If it returns negative, there's a mistake, I think, obviously. Let's see what it says about the return value. Return the current file position. Okay, you can use a 64-bit. Okay, we don't use the liar mode, I never do. So it's going to tell us where it is. Now, sorry, -1. On error, these two functions invoke invalid handler if you have one. If allowed to continue, the functions return -1. Okay. Now I can say if that's equal to -1. Alright. That won't be right. Well, that be strictly correct. Then return. Now I know that that's a positive value. size of the file. Think of these long things as not as quantities, but as positions, and these are amounts. That's the way I like to look at it. So this thing wants an amount, not a position. So I'm going to give it an amount of step 2 read by specifying, I've already forgotten the order, element size and count. So the element size here is 1. Now, I don't want to hang my system, so what I'm going to do is just set these both to 1 first. So that's 1 byte, right? It should be equal to 1. And files read not equal to 1 is success. 0 is success for program. If the number returned from the entry point function is turned by the operating system into something called an error level or return code for the program's execution. So this number does get outside. Now, is this going to compile? I think so. Why wouldn't it? C++ file. I have 2 of these in here. You have to have, if you have less than 2, then you lose this tree. It's quite a pain to get back. But what I want to now, I made a mistake. Unsigned. I think byte is defined. We'll give it one element. Oops. Oh, same day. That's perfectly safe because we're only going to read one byte. Of course, there's more than 1 byte in that file. Let's see, okay, right. We'll use those in a minute. Now, step up to here and just point something out. Okay, well, let me just run through the run over it. I mean, here's our file pointer thing. Is that not what it's called? It's not there. It's in docs. Let's try that again. I just want to show you what the members are of this file struct. Well, you can look at them in the header file. There's something called pointer, base, flag, an integer number, carb, off, and all this stuff. Okay? Let's see what this, if this fopen succeeds, what does it put in there? Well, it did succeed, no error. So everything is zeros except for this, and what that is the what they call a file number, or file, not a file handle, a file number. It's an index into that job file table thing, right? Zeros, I keep forgetting the order. Standard in, standard out, and standard aux, which is a COM port. Is that right? Yeah. And then the next number is the first file that you open. There's a flag here set. I don't know what its meaning is. Now I'm going to seek to the end of the file and see what happens to this. I believe that this thing, either this, or was there something called offset base? Well, let's see. Now, if anything changed? Nothing's changed. Same. Okay. Well, let's see what we get for this. Well, it's certainly able to retrieve the size. So obviously the size is not, the size of the file is not, at least currently, in this structure, right? It's only using this 3. All it's got to go on, right, is this flag and this number 3. And this, if this is a flag, then the only thing it's got to go on is the number 3. This function call, right? There's no other information in this struct, unless there's something associated with the pointer value, but I doubt it. Okay, so we got the file size. Now I'm going to read just 1 byte. And, now a whole bunch of things changed. Something called buff size became the value 4096. That's one sector, one disk sector, the smallest addressable unit on a disk, any kind of disk. Well, nowadays, it would depend actually on your drive. If this was on my F drive, this might say 1024. But in memory, though, this is a page, and that's an important number. The flag has changed. This didn't change. Now, what's this number? This looks like the file size. Well, I could switch to hack. But anyway, 631FO. Does not. It's 40,000 something. And the file size is 6F. Oh, 13FO. Oh, there we go. That's still not the file size. 6313FO. Oh, wait a minute. But what if I add 4096 to that? Well, it's not going to get anywhere near the end. Okay, now this one. Oh, no, it's not an offset from that position. PTR. Well, if this is it looks like an allocated memory. It's a pointer, obviously, right? This here is a pointer to malloc memory, but it hasn't been filled with anything. This is malloc, but not used yet, right? CD. fill with CDs. Change directory. Now, what's in buff here? Buff? Where's buff? CD. Is it possible that that's just, no, it can't be. The first character of this file is, it's not this number. It's not CC. What is it? It's the first character for UTF-8. Huh? Oh, it's not there. Oh, I've got it open. That's why it failed to open it. That's this one. It's EF. Why didn't we get an EF back? We got CC back. Let's try that again. That's odd. Oh, because we're not. I forgot to seek back to the beginning. Jeez. Sorry. See how easy it is to make a mistake when you have to do this manually. Now I believe that the call will succeed. That, I guess, I didn't even check, but I guess this must have been set to 0. Now that it succeeds, maybe those buffers will be filled with some data. Now, I shouldn't have had a problem with reading that file. I don't know why it's down. I'm not opening it right. Okay, there you go, see? So, there's 4 kilobytes worth of text that I'm not going to use. So I can't actually read anything smaller than in this case 4K. I am curious though, if I put it on my new drive, which I set the sector size to a smaller value, this makes my life easier. Let's see if it comes out. I think it's still going to be 4096. Okay, now my goal here with this, sorry for wasting your time with this. Let me see how much I wasted. 20 minutes. It's clear to me that nobody is using this overlapped IO, and it's clear to me as well that everybody should be, and that the reason we don't is either because we're not aware of how important it is. In my case, look at that. Oh no, it is 46, okay. I thought it was different. Either they're not aware of how important it is, it's got a different color, or they just, don't know how to do it or something like that. And I went and I looked online and I downloaded an example. Okay, and it's always the same for these things. I just want a simple example for a file, right? Don't start with the complicated stuff. And this is supposed to be like the simple, no-brainer example. Here it is. Where did I put it? Here. I thought I might actually learn something from the flyer. But no. Nothing to learn from this. Default port, URL length. Like, wait a minute. What are you talking about? Okay, now we're defining an O stream operator to print out times and dates. Okay. MIME type from path. Like the topic is asynchronous IO, right? Now, what's all this about? Oh, memscan. Couldn't you just pretend you already know that? Okay, overlap. Fine. Connection. Alright. Socket. What's a socket? Internet. Transmit file buffers, right? Like, wait, accept, SOL socket. I mean, already I have no idea what the hell is going on, right? This is a very small file. This is supposed to be an example of how to use asynchronous, how to use this overlap. But it turns out that you don't need to know any of that stuff. And it applies to regular files as well as the internet. And you can make a much simpler example than that, just for a regular file copy, which is the one that's messing up my life all the time, and probably yours too. So my plan here, I've written it out. I'm going to write down, without using any of my fancy tools, just code that you can compile yourself, that should compile on any compiler, and should run on any version of Windows, and will behave the way this function behaves, but the implementation will be asynchronous IO, like I have. Okay? Now I can start writing it. Now the functions, I couldn't find a good example, so what I did was I actually went to the help system and tried to understand these functions. I knew a bit about this, I knew a bit about this, and I knew about these three, but I didn't know anything about these two. Okay? So really, for me, there were just two functions to understand. But I wasn't sure that which ones I did need to understand. I found out through the help system, believe it or not. I believe these are the only functions that I use, the base functions. And the code is thread safe. There are no multi-threading issues. Okay. It's a blocking call. Many threads can call that same function at the same time without causing any conflicts or dangers. Alright? That's the function that I'm going to write. Now, to begin with, let me first explain how it works. You open a file, maybe I could write it down in steps. So these are these steps. First, you have to open a file, but you have to open it in a special way. the file. So given a file that is not already open by another process, the file's already open, that you can't do this, or you shouldn't attempt to. So, so you open a file for exclusive access. So immediately you're going to fail if the file is open, even for sharing, with sharing enabled and all that. You should just fail in that case. You, the function writer, this is the steps for the person writing this function. I'm writing this down here so that people can just blindly copy this code and start using it. Okay, and I'm gonna put a link to a zip file and you can download it. But for those that want to understand how it works, they can watch this part. Those who don't care and just want the code, you can skip straight to the end, download the code. It'll, paste it to a header file somewhere and use it. And once you're using it, your program will run much more efficiently and won't end up stalling the system. All right, the file has to be opened. File must be open with the special flag. I don't want to scare you by letting you see the other page. It has to be open with this flag. But that's not the end of the story for opening the file. Now, there's another method for doing this that I haven't tried yet, but it's one method that works and one's enough. All right. Now, what's the next? The next step is to create something called an endpoint. It's called a completion point. Create a so-called IO completion point. There's no point or place or anything. It's just the word that they use. Okay, it's probably a not very well named thing. This completion point idea, but you don't have to worry. All you do is you call a function and it returns you a handle. That handle is something like a token, let's say, that can be associated with an asynchronous file operation. And so the next step is to associate this completion point with the file that we've opened. So that's step 3. The completion point handle. It's a handle, just like a file handle, with the file handle. So we got 2 handles, and there's a special function we call this function. Okay. Oh, port, not point, port. Sorry about that. Associate the created completion port with the handle. This has to be done in 2 steps. You can't do it. It's, in fact, it's done by calling this same function twice, but you can't do it in one call to this function, unfortunately. And I think the reason is because the function is so overloaded. It would be it would become more difficult. You'd have to introduce flags, extra flags, and things that are not necessary. The way to make this thing is essentially you try to associate a completion point with nothing, right? And that it creates one. It's like a malloc. It's like doing realloc of from 0, right? That causes a malloc, and allocate something, and then calling realloc again, but with the thing that you got back. In fact, it's just like realloc. Alloc and realloc and realloc. These two steps are like p buff equals realloc no, right? And then no 10 gives you 10 bytes. Realloc 20, I guess. It's not exactly the same, but this first step gives you a thing that you can now do something with. You can make it bigger, grow it, or shrink it, or something, or free it even. If you put a 0 here, that frees the buffer. Anyway, not important. All right, so that's the third step. And now that we've got the completion port and it's associated with the file handle, we need to get the transfer going, right? We want to start the transfer. The idea is to start reading that file, and this is where I got messed up, because I opened a file with this fancy flag, right? I looked at the help, and the help said that when I read, it would be handled internally, and I wouldn't have to do anything, and it would do what I'm trying to do. But in fact, no, it's just a regular read. It was blocking, and it caused all the badness that the mouse stopped moving, and as usual, right? But after you've done this, after you've associated the completion port with the file handle, then to begin the asynchronous transfer is you do that by calling that read file. Begin transfer by calling read file. This base an API function. All right, and now the function is going to return immediately with the value 0. And so if this is a success, so we expect read file to return 0. 0 in this case normally would be failure, but in this case that's what we expect. And get last error should be equal to IO pending or something, some flag, something like that. Okay. So now the thing is ready to start doing the transfers, and who knows? It might, the data may have already been transferred and placed somewhere for us to pick it up, right? But the read files doesn't pick it up for us. To get the data, right? Well, first, this read file needs to be called with some, that's true, I forgot to add, by calling read file with valid LP overlap entry. I'll have to tell you about that later. But this LP overlapped thing is some static memory that is, it's not something that you declare on the stack, just like with anything that's asynchronous. Once the IO operation completes, some information is going to be stored into this structure. Okay, so this thing has to be I say static, meaning static as in unchanging, not keyword static. The actual meaning of the word is non-transient, not temporary. Is non-temporary storage. So it has to live as long as the transfer is going on. So at least until the end of one of these transfers. Till the operation. This begins an operation, and when the operation completes, this thing must still be valid. Is what I'm trying to write. The transfer of an entire file may involve many reads, right? But you don't have to use the same LP overlap. You can change it if you wanted to. Now I'm not going to tell you the details yet. This is just an overview. Now, you could, if you wanted to, I suppose, could you? One of the parameters to the is it this one, or is it something, or is it this one? This one. One of the parameters to this function is the maximum number of threads that can listen on this to this port. Okay, and the default, if you put 0, you get the default, and the default apparently is the number of processors on the system. Okay, which I think makes sense because at most both processors might be doing a transfer once, so you don't gain anything by adding more threads, right? I only used one thread, and maybe I didn't need to make that thread, but I found that it was simpler, especially because I have a tool for making threads, and sorry. And I wanted to leave it flexible enough that if somebody wanted to, let's say, have my read function do like this read function and return immediately, that there would be that thread doing its waiting for the data to come that you could check for later. So I designed the function internally. You don't see any of that stuff. The user doesn't see it, but if you wanted to, you could modify it to mimic the behavior of this function. All right. So once this step 4 is done, you can do what I've done. Create a thread that will listen for listen on the port, basically, for a signal. Now, if this is an efficient listen, the function here, get queued completion status, is similar to wait. Wait for single object. You could use wait for single object too, by the way. There is a handle involved in all this, a signal handle. And then when the IO is complete, this function will return true. Okay. If it returns false, there are several cases you may or may not want to handle. One could be that it timed out, that this thing takes a timeout value. But you could specify infinity for that, and so then if it fails, then it's definitely an error of some sort. That could happen too, but it's up to you how you want to handle that. Once the thing is complete, and call the magic function get queued completion status. What we've done is we've queued something. We've queued an IO operation, for the operating system to deal with when it has time. And there's a function you can call that takes, like I just said, a timeout parameter, but it's an efficient call with some timeout. So you could choose infinite because it should complete, or it should either complete or fail. If you chose an infinite timeout value, then this thing is either going to succeed, or if it doesn't succeed, then it fails. It can return, like timed out. If I set the timeout value to 0, then this thing would return immediately, right? And tell me whether or not the operation is completed. So if you wanted to, you could use this just as a flag. After the thing does complete successfully, after success, then actually just simply calling this function from within a thread associates with that thread the completion port. No other threads will be able to retrieve data from that file. If I read the help correctly, just copy this F1. Next video, I'll show you the code. This is how I learned how to do it, just by reading the help. See, there's the wait timeout. The word thread. Okay. So yeah, the function associates a thread with a completion port. Okay. A thread, I'll add it backwards. A thread can only have one completion port that it services, and so that's why you have to make another thread, right? Because if you use the main thread, right, then that's it. You can never use it again for another file open. See what I'm saying? So for each transfer that you begin, you should dedicate one thread for it. It's just like RPC, just like remote procedure call, where one thread is dedicated to servicing one client, right? If there are two clients and you have an RPC server, then that server will have two threads, one servicing one client and another the other. 3 clients, 3 threads, and so on. Well, in this case, for each asynchronous IO operation, there will be one thread that is dedicated to servicing that request. Okay. Okay. This is all the stuff I read before. So that's basically, in a nutshell, what it is. I thought I had. Thank God I didn't have to figure this out. I was sure that this was always my stumbling block, because they always seem to try to push you towards this function, right? And I look at it and it's a god awful mess. And then I would try read file with the overlap, and it would, it was synchronous and blocking, and um, not even not a marshaled thing. It's just like in my same thread, doing it to read as fast as possible. But after reading the help very, very carefully, you have to set up the 3 things first, right? The completion port, associate the handle with the port, open the handle with a special flag, then and only then, and provide a proper overlap structure. Then and only then will read file become asynchronous. You read and it returns immediately. Then you must create a thread in order to service and read, basically, from that port that you've created. So I guess it is a good name. It's like a port of entry where the data is coming in. Now another thread could also use that same port, right? That's what I had backwards. So that's why you can have, that's why there's a parameter, a number of threads, right? And there's one of the values that is passed into this function as a returned value is something called a completion key. All right. Now, I thought that this was something that I had to specify, or that I had to get from somewhere. But I just used the number 7, and it worked fine. I used my this pointer, and it worked fine. And the number comes back, the number that I specified in somewhere else. in creating the port also takes that a key value, I think. Yeah, right? So this thing is a thing that identifies essentially which file which file, you could put the file handle, I suppose, which file the completed request was associated with. But further than that, if you were reading a file from several threads, and let's say that the packets are coming in asynchronously, it's not coming in linear form, right? Then one might well, no, it wouldn't change though, would it? I thought maybe you could change it. Maybe you can. I thought maybe you could bump it up, and no, you wouldn't need it. You wouldn't need it. It's all it's all well defined, because when you make the call to read, you have to specify from which offset in the file and how many bytes, right? And when the thing returns, it doesn't matter. Depends how you do it. One way you can do it, like the way I'm going to do it in this example, is that make a great big buffer, size of the file, right? Let's see, this is the total file size. Whoops. And this is my great big buffer. What I plan to do is, instead of doing what I have in my own code, having a separate buffer for the transfer, which I use to fill up another buffer, is just use this big buffer directly. So, like, I'll specify at position X, I want you to read this up to position Y, right? And when the function succeeds, that part of the buffer has been filled in already. I don't have to take any further steps, right? Now the question is, how do you know which one, if there were two threads, and this is, let's say, request 1, and we have 2 requests. Let's say another R2, U and B or something, or U and Z. I think that the thread that issues the request is the one that receives the notification. I could be wrong though. Say, but that's just, if you use one thread, then you never have to worry about that. With 2 threads, you might have to. Let's see now. Allows waiting thread to process a packet. If a running thread enters any wait state, I see. There may be a brief period where the number of things that exceeds that reduces the number. It seems like any thread can pick up any request. So how do you know which request it is? And that's what I thought this key was supposed to be for. But no, that's just, this is only done once. A per file key included, it just identifies the file. And it's the same value in every completion packet. Okay, well that's still useful, right? If you have a program and it has many threads, and you're receiving notifications, and you want to verify that they're all intended for the same file, you need to check this key. But I can't see how it could go wrong. because that thread can only be associated with one port, right? So you could just assert that this is the one that you initially specified. I don't know about that. It's totally unimportant. The rest is just reading some code. You just keep repeating this until you've read all the bytes. In this case, with a single thread, start at 0 and I ask it to read up to, let's say, 8K of bytes. When the thing completes, then I tell it to read from here 8K of bytes. I don't do any copying. I don't have, in this example, I won't have to, because the buffer supplied happens to be the result buffer, right? And if I keep track of how many bytes have been copied, then when I get to the last one, there might, I might have to subtract two numbers and make sure I'm not off by one. And that's it, right? And the whole thing, as far as the user is concerned, is synchronous. It's like a marshaled read that the operation is being performed in a different thread, and now I know why. And but the user doesn't need to know about that, right? And they don't. I don't. In my program, this is the last thing I'm going to show you, because I just put it in my program, and I changed the interface slightly. I changed it into more of a function call, whereas I had a struct. It still is a struct, but the function that I call is a static function. So that a static function is just a function, right? You don't need any dispointer. What? Okay. Oh dear. I don't know how that happens, but anyway, I'll show you where I do the read. A function called read file. Somewhere. The header file. Oh, come on. Open file? Load file maybe? Open file. Okay. So this is how I use it. My version returns a type of buffer. Okay. Smart pointer type thing. But this by this line. That's not exactly correct. It won't be null necessarily. Be empty. Oh, come on. It's pretty. I want to change it. Sorry, this is just my own thing, but this is a blocking call. It just takes a file name and it returns a buffer. That's it. It's very simple. It's easier to use than fopen. Or if it's null or two possibilities. Really, there's only one possible return value, but I may change the implementation. So in both of these cases, there's nothing to do. I didn't get anything back. Okay, so the next lesson, it won't be using my fancy classes. It's going to be straight up C++ code. I'm not going to write C code. Sorry. I can't deal with the fact that you have to declare all the variables first. That's just too much for me. See you.